Welcome back, everybody. Today, 7.3 is coming your way. We're going to be showing triangles are similar using a postulate known as the angle. Before, we've talked about congruency postulates. Now, in the next couple of days, we're going to be talking about similarity postulates. Okay? The very first thing I want you to do is I want you to write down the angle similarity postulate. So please write this down. All right, it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And the reason behind that is we need to have all three angles congruent to prove similarity. Well, if we have two of those angles, it is going to be, that third one has to be similar. Remember that the triangle's interior angles theorem, when all of those add up to equal 180. Okay, so we are going to be moving on. So the very first one, what I want you to do is I want you to determine the triangles are similar. And I'll show you how to do that. And then we're going to write a similarity statement. So this very first one, as we look at this is how the process goes. Okay, we want to figure out, we have angle A is 43 degrees and we have angle F is 47 degrees. We know that angle B and angle E are congruent to each other. Why? They have that 90 degrees. What we need to do is we need to figure out the other two angle measures. Okay? Now, you may already know in your head if they are similar or not, but we want to make sure that we can explain our answer. So the very first thing is we want to figure out what angle C is. So angle C is plus 43 degrees plus 90 is equal to 180. And we know that because of our triangle sum theorem. All right, when we add up all of these, we get angle C plus 133 is equal to 180. And angle C in the end is going to be equal to 47 degrees. So we know that angle C is 47 degrees. Do we have to figure out what angle D is? No, we don't. And the reason behind that is because of our angle postulate. So, because angle B is congruent to angle E, and angle C is congruent to angle F, the postulate or the similarity statement is going to be triangle A, B, C is similar to triangle D, E, F. Okay? And that's going to be our similarity statement. How do we know that? By the angle similarity postulate. Okay? And I do want you to put that word similarity in there when describing this postulate, because tomorrow you're going to find out two postulates that we have talked about in the past as far as congruency, and we need to know that we are talking about similarity and not congruency. All right? So next one, I want you to write this one down. Write this next problem down, and I want you to explain if they are similar. If they are similar, then you can write a similarity statement. Give this one a shot. All right, so are these similar? The answer, plainly yes. And the reason behind that is going to be angle A. We know that angle A is going to be congruent to angle D. Why? Because they're both right angles. We also know that angle BCA is going to be congruent to angle ECD. How do we know that? Well, those are our vertical angles. Okay, these are vertical angles, and the reason why we can definitely say that is because of that vertical angles theorem. So, can we say that these two triangles are congruent? You betcha. I know that triangle BAC is going to be congruent to, not congruent. They are not congruent. They are going to be similar to triangle EDC. How do we know that? Angle, angle, similarity postulate. Okay, now if you notice, this is almost in a two-column proof where this would be given. Now, if you want to write a two-column proof, by all means do so. If you want to write it in a paragraph form, go right ahead. It's your choice what you want to write it in. Okay, awesome. Now, in this type of a problem, what we need to do, it says explain why triangle ABE is similar to triangle ACD, and then find CD. So, when we are figuring out that triangle ABE and ACD, we know in this lesson we can prove two angles are congruent. So can we prove that in this? Absolutely. Okay, we know for a fact right off the bat that angle ABE is congruent to angle ACD. Notice my right angles here. Okay? Next, we need to find a second angle. And if you pull these apart, pull these two triangles apart, it will look like this, where this is AEB. And this would be 5 and 9. And this other one is ADC. Okay, we both know that they are right angles. Where would we have another angle congruent? Right here. Notice that. What do we know about those? They're both angle A. Okay, so because of that, we can say that angle EAB is congruent to angle DAC because they're the exact same angle. They're angle A. As you can see up here, they're both angle A, so they have to be congruent to each other. Alright? So now we have two angles congruent. We can safely say that triangle ABE is similar to triangle ACD because of the angle-angle postulate. Alright? Now, we figured out that they are similar. Now we have to figure out what CD is. And the way we do that from here is we know that because they are similar, their sides have to be proportional. So we have to set up a proportion. Okay? So this is what a proportion would look like. I would put 9 over 5. Again, I'm talking about this small triangle here. Okay? I'll erase these little arrows up top. Okay, I put the bottom side over the large side. Or sorry, over the height side. So the base over the height. Okay, on the other side, in the same triangle, or in the same proportion, I need to do the exact same thing. I need to put my base over my height. Okay, my height is going to be x, right? So my height is x. Now what's my base? You're looking at it and you can see that the number is 3. However, that entire segment of AC, we're talking about this big triangle here, that's more than just 3. That's 9 plus 3. So it's going to be 12. Okay, so now we have a proportion of 9 over 5 is equal to 12 over x. We can say that because we know that they are similar. Cross multiply, and you come up with 9x is equal to 60, and x is going to be 6.6 repeating. Okay? So, very first thing is you need to prove or explain why. This is my explanation. You can write it in paragraph form if you would like, or you could set it up just like that. Next, you have to set up a proportion to figure out what CD is. Okay? Make sure that you have the exact same ratio on both sides of the proportions. Alright? Give this next one a shot. Try this one all by yourself. See what you come up with. Make sure you explain first. Explain and then find what RT is. Give it a shot. All right, so when you look at this, you will have angle RSV. We know for a fact RSV is going to be congruent to angle RTU. Why? That's given to us. Okay? We also know for a fact that angle SRV is going to be congruent to angle TRV. Okay? This angle is going to be congruent to itself, essentially. Okay? It's that reflexive property. Okay? So now, because we have two angles, we know that triangle RSV is going to be similar to triangle RTU because of the angle-angle similarity postulate. Okay, so now I got that first step done. Check! Checked off that first one. Now we need to figure out what RT is. So let me see your proportions. Just kidding, I can't really actually see them because I'm taping this lesson and I can't see through this iPad or your computer. Okay, moving on. So when I look at this, I need to set it up. So again, I am going to set this up as 8 over 10 is equal to 12 over x. Now, how do I know that I can use x? Okay, I can use x because I don't know what RT is. I don't know this entire segment. So why not? I know half of it. I know what RS is, but I don't know the entire thing. All right. So the entire thing is x. So now I'm going to cross multiply here. And I will get 8x is equal to 120. Okay. From here, I need to figure out what x is, which means I divide by 8. And x is equal to 15. Okay, so I figured out what RT is, which is RT is equal to 15. Now, when you look at this problem, you may have set it up a little bit differently. Okay, and that is that's okay as long as you set up the ratios the same on both sides. If you look at this, I used this 8 first, so kind of that right side of the triangle over the top side of this triangle here. I don't know. And then on the other side, I used the right side of the triangle over the top side. Okay, I know that's very non-mathematical words. In other words, okay, I put SV, which if you look at this statement right here, I put SV over RS, which is the first one. Okay, then I used TU, which is in the, again, second and third position in my similarity statement, over RT, which is in that first two positions. Okay, so I needed to make sure that ratio was the same. All right, that's all I have for you today. Nice work. I'll see you later.